Hello everyone. In this video, we'll be looking at the Node Graph API. This API allows you to manipulate the Node Graph in many ways. As you can see, if I type in Node Graph API and then dot, there are a lot of methods here that you can use. Today we're just going to focus on some of the main ones. And the first one we're going to look at, I'm not even going to type any code. I'm just going to hit Shift and then middle mouse click and drag on my test material over here, and it gives us the code. Node Graph API .get node and the name of the node. I'm going to store that in a variable. So we'll say test material node equals, there we go. The next thing we're going to look at is creating a node. So Node Graph API dot create node. And you can see here from the prompt, it needs a type and a parent, and if you don't give it a parent, it's going to equal none. So you can actually create a node that doesn't have a parent and not exist in Katana. You won't see it in the node graph because it needs to know where it is actually in the node graph hierarchy. So for example, we could set the parent node to be the group node and it'd be placed in here. But if we want it on this top level here, we need to know what the root node is. So before we create our node, let's get the root node. We can do that by Node Graph API dot get root node, and we can store that in a variable called root node. We'll run that. Now let's create our node, and let's create a prune node and give it the root node as its parent, and then store that as prune node. Okay, let's run that. Okay, our prune node has been made. Excellent. Now, depending on what node you make, we'll have different methods available. There will be a base line of methods like adding input ports, deleting, etc. And then there are some node types that have their own methods. So let's look at the test material node, and it has its own special get scene graph location because the material node creates a scene graph location from what you set here. If we run that, it gives us the location. So root materials, test namespace, test material. So you could use that to find its scene graph location and use it. Okay, so let's say we want to take this prune node and place it underneath our test material node. How can we do that? Well, first of all, we could get the node position here and then set this node position to be the same as this, but then offset in Y. So we'll do Node Graph API dot get node position, and we'll give it the node of our test material node. And we'll store that as test material pos for position. And then we'll do Node Graph API dot set node position. And we'll give it our prune node. And then we'll get this position. And the position is X and Y in a set, so we can get X from 0 and then Y from 1, and then we can move it in Y, so we'll move it minus 100 because Y goes up like this, so X would be the same and then we'll go down in Y. We can just run this. Our prune node has moved now to below the test material. Next thing we can do is connect these two nodes up. So we could do output port equals, and we'll take our test material node and we'll get output port. So you can get output port and give it a name. You could say out, or you could say get the output port by index, and you could give it index of 0 because there's only one. Now different input ports have different names. You can see this one's called in, and this one's called A. So I normally like to use the by index, and if you're cycling over code, it's good to use those instead of the names, and I'll show you that in a minute. Okay, so we've got output port, and we'll do the same. Input port equals, and then we'll get our prune node. We'll say get input port by index, and we'll give it 0 as well. So we've got our two ports, and we need to connect them together, so we can do output port dot connect, give it the input port. There you go. Excelente. Let's see a little bit of code on how we can create a few nodes and connect them together. So what we can do is have a list of different node types. So a primitive create, attribute set, gaffer3, and a render node. And then we can have our prev n, which will be our previous nodes. And we'll first of all set this as none. And then what we're going to do is we're going to enumerate over this list of node types. So we'll get an index and the value. And then we can use the create node to create our node type and create it at the root node that we've already set as a variable. And that's going to give us a node. And then we can set that node's position, and we're going to use the index to position it in Y with an offset of 75 each time. And now if there is a previous n, so we've already created a node, then we'll get the output port using the index and the input port using the index, and we'll connect them, and then we'll store our node as a previous node, so then we cycle through, we can use that. Okay, so let's run this code. And look at that. We've created 4 nodes and connected them all together. And you can see here, you've got A and in and input, so all different names for the input, so that's why it's handy to use the index. Now there is another way of being able to connect nodes together, which is a little bit sneaky, that I thought I'd show you just in case. So there is another API that's called the Package Supertool API, and from that it has a node utils. So if you're building a Package Supertool, it has some handy features in it, and one of them is this node utils, and we're going to use that instead, just as you've got another option. It's the same kind of code. We've got our node types, and then we've got an empty list of nodes. And as we cycle through our node types and create them, we're just going to append this list with the node that we create. And then we're going to use the node utils.wireInline nodes, give it the root node and our nodes, and it's going to connect them all together. Let's run that. And there you go. It's created this list of nodes instead. Okay. Now, the Node Graph API has lots of handy get methods that you can use to get nodes that have certain criteria, like if they are all selected or being viewed or edited. Now let's do an example of getting all nodes of a certain type. So all of the material nodes for this example. We can do node graph API dot get all nodes by type. And you can see that include deleted equals false, so you can actually get all the nodes even if they've been deleted, and sort by name equals true. And we're going to get all material nodes, and we can store that as material nodes. Okay, so now we have all the material nodes in our scene, even if they're like nested inside a group. What we're going to do is we're going to cycle over this list, and we're going to get parameters from this. So for n in material nodes, we're going to get the name of our node, so n.getName, and we're going to store that as node name. Then we're also going to use the method getParameter, and we're going to give the parameter name, which is namespace, to get the namespace here of our material. If you hover over it, it will tell you the name. So if your parameter is nested inside groups, it will have like all the different group names, ... all the way down to your name. And then you can add that in here. And also you could just middle mouse click and drag if you're not sure of the name of the parameter, and it will have your get node, the node name, .getParameter, namespace. So that all looks good. And then from the parameter, we actually want to get the value of the namespace. So you use the .getValue, and you have to give it a time. Now that's because parameters can have keys, so you can keyframe it to be different values. And we want to give it the time of 0 because it is just a static, doesn't change over time. And then if that namespace is 0, then we can print out to say the node name, as no namespace, and use the format to give it the node name. Otherwise, the node blah as namespace blah. Let's just get rid of that. See that? Okay, and I'm going to run this, and it gives the output. The node test material has namespace test namespace. Bark material has namespace wood. Gold material has namespace metal. And these two have no namespace. It's pretty cool. Now, the next thing I want to go through is node graph API dot load XML from file. So, what actually is a Katana file? When you save it out, all it actually is a gzipped XML file. So if we give it the file name, so let's give it the file of the file name of the file that we're actually using right now. We run this. Oh, 2 brackets. It gives us the XML. And this is really handy if you have a problem, say for example, you can't open the Katana scene and it's giving you an XML error. You can actually look at this, export it out into an editor or something like that and figure out what line is wrong and try and fix it. And you can also use it to, extract some of the XML from here to put it into another scene, etc. And the last thing I wanted to talk about just quickly is there are a bunch of util methods that you can use. Things like collapse to group and delete all non-contributing nodes and duplicate nodes, all these kind of things. And these are some of the things you would see in, say, for example, the edit menu where you have duplicate, delete all contributing nodes, etc. So you have these as part of the util if you want to use any of them. Okay, that's an introduction to the Node Graph API, how you can create and manipulate nodes. Happy coding, enjoy.